Given an example as discussed previously with this input signal and initial condition, but now we want to determine zero state response using classical method. From previous example, we have this equation for particular solutions. For zero input response, we want to solve this response using input signal with zero initial conditions, y minus 1 equal to 0 and y minus 2 is equal to 0. We cannot use this condition anymore. So for auxiliary conditions y0 and y1, we need to generate these two. So we reconsider the equation, the difference equation given in the question. So now we want to generate the auxiliary conditions for n equal to 0 and n equal to 1. So we plug in this value of n into this equation. So for this initial condition, we have to set it is equal to 0 for zero state response. Okay, the initial conditions for zero state response is 0, but it depends only on the input signal. So we plug in this n equal to 0 in this equation. So now for initial condition equal to 0, so we can solve the first auxiliary conditions y0 in this case equal to 1. The next one, we want to determine the auxiliary conditions n equal to 1. So we plug in n equal to 1 in this equation. So again, the initial condition y minus 1 is equal to 0. So we want to determine y1, and we can use this y0 as determined previously. So now we can determine y1 equal to 23 over 6. So based on y0 and y1, we can determine, we can back to the zero state response, which is equal to homogeneous solution plus particular solution, where based on this one, y0 equal to 1 and y1 equal to 23 over 6, we can use this equation to use for n equal to 0. We plug in n equal to 0, equalize this equation with y0 which is equal to 1. And then the next one, we use this value of y1 equal to 23 over 6 for n equal to 1. So we plug in n equal to 1 in this equation. So we have the second equation. Based on the both equation, for y0 and y1 value, we can solve for a and b as the previous example. Okay, so now we can construct our zero states response, which is based on this equation, and determine value of a and b. So we have this one from the homogeneous solution. This is a, this is b, and we also have this one from particular solution.